Okay, I want to convey to you the meaning of a very important term known as polarization, because you have neurons with a membrane that can separate charges. In the case we've described at rest, right, significantly more sodium on the outside of that membrane, a lot more potassium on the inside. Both concentration and electrical gradients maintained largely because of the operation of that pump, that sodium-potassium pump, which, by the way, is, of course, a transporter, right? A dual directional transporter. It's, fighting forces, to, like the concentration gradient force, right? To push sodium on the outside. It's also fighting the electrical force, right? To push sodium on the outside because it's more positive out there. Well, at rest, at minus 65, minus 70 millivolts, more negative inside relative to the outside, that represents a certain level of electrical sort of polarization. There's a difference in charge across that membrane, right? Well, if you make the inside of the cell even more negative relative to the outside, so let's say you go from minus 65, minus 70 to minus 80 or minus 85, right? Well, in that case, you're increasing the difference in charge at the amount of polarization. So we say that you are hyperpolarizing the cell. Now, think hard and read your materials to think about, how do you hyperpolarize a cell? How do you make it more negative on the inside relative to the outside? Well, to do it, you've got to move charges right across that membrane. You've got to actually either bring something negative from the outside in, right? If you can bring some negatively charged ion from the outside into the cell, well, you will actually, increase how negative it is on the inside versus the out, right? You can also take something positive from inside the cell, right, and move it across the membrane to the outside of the cell. That will also hyperpolarize or make the neuron, more negative inside versus the out. But consider, of course, that in order to move charges across that impermeable phospholipid bilayer, you need specialized machines, right? You need proteins that can open holes to let, something negative, let's say, from outside the cell. And think of a candidate. What's a negative ion that's found outside that cell that can potentially move across inside the cell and make it more negative on the inside, versus the out? Well, it'll turn out that sodium, of course, comes in from table salt along with chloride ions, which are located on the outside. So it turns out if you open a hole in the membrane to chloride, there's a lot of chloride out here, very little on the inside, and the chloride will work its way across, into the cell, and it will hyperpolarize the cell. Remember also, we have channels even at rest in a membrane that let potassium leave the cell, right? And potassium tends to be driven out of the cell because it is in higher concentration on the inside of the cell than outside. The concentration gradient force pushes it out. If you were to open more channels to potassium, well, more of it would move out, driven by that concentration gradient force. And if you're moving a positive ion from the inside of your cell outside, well, you're going to make it more positive on the outside and more negative on the inside. You're going to increase the polarization again, and you're going to hyperpolarize the cell, right? Okay. So if the inside of the cell becomes more polarized than rest, right, up to from minus 65 to minus 70 up to minus 80 or so, we say that it's hyperpolarized. In contrast, if you were to reduce the difference in charge between the inside and the outside, right? If you were to make it more positive on the inside relative to the outside, to go from minus 65, 70 to minus 55, for example, this is, you're reducing the difference in charge, right? You're reducing the polarization. So we say you are depolarizing the neuron, right? And again, consider how you might do that. You'll again have to move charges across the membrane, right? And a particularly good candidate, for depolarizing a cell is the sodium ion. Because remember, it's a positively charged ion found in high concentration on the outside of the cell, right? And inside of the cell, there's very little sodium, and it's also negatively charged. So in the case of sodium, all the forces are aligned to drive it in rapidly should you open holes to allow it to enter, right? So if you were to open some channels that allow for the passage of sodium into the cell, you would have sodium enter, and you would reduce the charge difference, and you would be depolarizing that particular neuron.